Hello, everyone. We at Sci-ROI strive to help the Indian diaspora in STEM research transition back to India. The Blocks team at Sci-ROI does so by bringing you some accounts of faculty which recently transitioned back to India in our new Faculty Perspective series. The Spotlight series focuses on people who transition back to India after their PhD to pursue some unique career options outside of academia. Our Evolving Trends in India series takes an in-depth look at, as the name suggests, some of the emerging trends in Indian research ecosystem. However, after transitioning back to India, getting yourself established in a particular research field is no easy task. It is possible that you even might be one of the few people working in a new cutting-edge research field in India. Here, some words of experience can be very helpful from people who transitioned back to India a long time ago and established themselves in a new field. Learning from the challenges that they faced, the unique experiences they had will help all of us. Their outlook on the future and their advice to young researchers will also be very important. Keeping all this in mind, the Sci-ROI Blocks team has started a series called Forerunners to share the experiences of established researchers in India. As part of this Forerunners series, we have with us today Professor Sudipta Maiti. He is a professor and chair in the Department of Chemical Sciences at Tata Institute of Fundamental Research, Mumbai. Professor Maiti's research focuses on protein aggregation and folding, peptide-membrane interactions, and neurotransmitter dynamics. He is also involved in the development of various fluorescence spectroscopy and imaging techniques. Professor Maiti is a fellow of the Indian Academy of Sciences and has co-founded and serves as the president of Fluorescence Society of India. He has played a key role in organizing the annual FCS workshop as well. He has also served as the secretary of Indian Biophysical Society, as well as the president of the International Society for Optics within Life Sciences. So on behalf of Sci-ROI, welcome Professor Maiti.
Thank you. Hi, Rohit. Hi, Atul, and hi, Somnath. Yeah,
hello.
Go ahead.
So the first thing I wanted, the first thing I wanted to ask about was what sparked off your interest in science research, and why did you choose to come to US for pursuing your doctoral research?
That's a tough question. It has been a long time. But I think I distinctly remember looking back, the two individuals who were important in me getting into science. One was my own dad. He was a professor of agricultural sciences, but he was unlike many others. He was married to his profession. So he was absolutely dedicated, knew everything about the field, always thinking, talking to the farmers, etc. He was a farmer's son himself. And that somehow, and a very rational man, absolutely rational man. So that I think when you see somebody like that right from the childhood, that something gets into you. And I had a grand uncle who was about my dad's age, though he was a grand uncle. He was again a professor of physics, and this guy was a master storyteller. And the reason that actually I was trained as a physicist, though I'm in the chemistry department, that I wanted to do physics was definitely because of him. You do have this little bit of, like your dad, but you always want to do something different, right? Say, no, dad, I'm not going to be like you. So I didn't want to do agriculture or botany or something. And this grand uncle was always telling stories about physics and physicists, which seemed to be a world where your arguments matter, your thinking matters more than your connections and powers and political things that. And if you're growing up in India at a certain time, those things are very appealing because the rest of the world around you seem to be going through different paths. And you know that if these things matter, maybe that's where I'll be comfortable with. And yeah, of course, all of us read about Feynman. He gave me some books, Feynman and all that. And you read those things and you, like many of us, look at the sky and think about the galaxies and all, and said, okay, I need to be a physicist. That was basically the childhood dream, being a physicist. And the only thing that you have to come to terms with is that, which was not very tough in Bengal, which is that money is not going to be a friend, okay? Especially if you're going to be an academician anywhere in the world. I think that's pretty much true. But in Bengal, that was okay. I mean, my dad was a professor in a college and never cared about money really. And that was an easy decision. And but that's the only decision really. So when I went and studied in IIT Kanpur, my an integrated physics degree, I always knew I had to do a PhD, I had to do some research, and I will be a researcher. And so, yeah, that's how it went. And why US was so obvious. I mean, it was very obvious because at that time, and even now to a large extent, the US institutes lead research. And so obviously the things that you read about, the papers that you read as an undergraduate student, you look at things that are happening and you know where they're happening, you'd like to get to and the textbooks that you read, you read as physicists, some of us, not all of us here are physicists. The textbooks that you read, you'll see Jackson, so you know that guy is sitting in Berkeley, and things like that. Ashcroft and Mermin for solid-state physics, that guy is sitting in Cornell. So you know those things. And born an wolf, and I was very, very, very pleased that I wanted to do a little bit of optics. I went to Rochester, and my first course, a cold September morning, was a mathematical methods course where ML Wolf himself walked in to teach, and that was quite something. So yeah, you might say that it's not a very logical way of deciding what you like to do, but it's like, when you're a kid, you are allowed to dream, so you just dream, try to live it as much as possible.
Yeah. So, Professor Maiti, we're curious. How was your experience of being an Indian grad student in the US, like almost 30 years ago? Even though India is quite far from here, now there are many Indians around, and there are many Indian stores and restaurants, and even we can video call our friends and family whenever we want. But back then, these options were very limited. So, how was your experience?
I'm so glad that you asked that, because nobody thinks about that these days. Boy, we had it great because we were really going to a foreign land. You guys don't. When I walked in, the first flight I took in my life took me to New York. Okay. I needed to buy a toothbrush and toothpaste, and I didn't know how to buy it. It was a supermarket, never seen a supermarket in my life. I was expecting when you go to till that time, I'm talking about late 80s. If you go to a shop, you point out to the shopkeeper, hey, that's what I want. Can you show me some of those? And he brings it out to you, says, sir, Babu, look at these things, what do you want? And you take one and you pay him and walk away. And here I was in a supermarket. Somebody asked me, there is a supermarket there. You can go buy those things. I had no idea what to do. I kept looking and kept looking, tried to figure out what are the other people doing. And it was almost, it was something very surprising that nobody was there to help me. I have to really go walk to the aisle, pick up the toothbrush, bring it to this guy, and he will just take the money. You have to do all the work, and nobody is there to entertain you. So that was something. I mean, so in a sense, as I said, you guys don't get to go abroad. We really went abroad. Everything was absolutely new, different, some frightening, some absolutely fascinating. Those roads where you stand on a little overbridge and there's a highway going below you, the speed at which cars are moving, the width of the roads, and there's something in a city, nobody's talking to anybody else. Those are slightly not so pleasant experiences that you want to talk to people, right? In India, you go to a market and you're a diffusing body, which takes a long time because you meet so many people that you know. And here, people are all in their cars. You don't know anybody. But when Rohit went in, before that, he has been to a supermarket, he has been to highways and all that. So it's nothing new for him. And almost getting to be like that when I came back in the late 90s. But in another 10 years, everything changed. So I remember, Rohit knows that guy. I had a graduate student named Kanchan, and I took him to it was maybe 10 years ago or so, took him to one of the biophysics conferences, Biophysical Society meeting, which I typically attend. So we were there in somewhere near LA. It was late and we just got out of the plane. By the time we reached there, it was late. We were quite hungry. And I said, Kanchan, who is going to look for some food here? Let's just try to tolerate our hunger. Tomorrow morning, we'll find out something. So Kanchan asked me, but Sudipta, aren't there things like Pizza Hut in this country? Nobody delivers pizza or something? That was, to me, something, because Kanchan was already accustomed in Bombay to have food delivered. I didn't know about pizza when we went there. I didn't know about delivery of anything. So when I first landed there 30 years ago, 1987. So yeah, as I said, you guys, we had real fun because we really discovered a new country. You guys don't. You guys know all about it. You see it in the movies, you see it, and you actually, some of you guys have been abroad before you actually live abroad. So no fun.
Yeah, I totally agree with you.
That's this thing. I remember somebody said that I was in Rochester, which is New York State, but it's about 4 or 5 hours of drive. Somebody's friend told other people in the Indian graduate student community, that guy is going to New York, okay? Jackson Heights. And all of us ran and says, can you get us a kg of moong dal? Moong dal, okay? And then, you know, that's what. And he came back with things full of this, that, and whatever. And my moong dal was there. And you know, nowadays in the smallest towns, you know, Ithaca is a place I just visited a couple of years ago before the lockdown. We go to the supermarket, there's a full Indian aisle, and moong dal is there. So that's how much.
Yeah.
It was fun. It was a lot.
Yeah.
However, I mean, okay, so yeah, go ahead. I'll not talk too much at a stretch.
Dr. Maiti, after your PhD in femtosecond vibrational spectroscopy at University of Pennsylvania, followed by pioneering work on multiphoton imaging of neurotransmitters, as well as fluorescence correlation spectroscopy during a postdoc at Cornell, why did you decide to come back to India and join TIFR Mumbai? What was your inspiration behind that transition from US to India?
This, I must say, is a bit personal, and you know, everybody has his own reasons. And for me, it was, you know, by the time I came back, I lived there for, I don't know, 11 years or so. You know, did a PhD and then a slightly long PhD and a slightly long postdoc, because the PhD, I left Rochester. I started it in Rochester, then I left it in between and joined University of Pennsylvania. It's a guy called Robin Hochstrasser, who I thought was doing the best science at that time about, you know, things that I wanted to do. So it took a long time. Then the postdoc also took a somewhat of a long time. Again, exciting times, but total became more than 10 years. So every time, never I thought that I would stay back there. And this was an issue with some of my supervisors with who had conversations with me, and you know, they advised me that you should look around because you won't get the kind of stuff, because the experiment I got to do needed femtosecond lasers and all. There were no femtosecond lasers in India at that time, just about 1 or 2, I think. So it was a hard decision, but you know, I was very comfortable there. But I always thought throughout these 11 years that you know, these people, my friends who are the Americans, have made a good country for themselves, and perhaps I should try something, you know, in my own little way to do that in my own country. So that has always been a motivation. I know that other people, I have many of my friends, you know, I'm from an IIT, 90% of them stayed back, and I'm in touch with many of them. Everybody has a reason to stay back or to come back. And, you know, there is no good way or bad way. If you're asking me, then that was my reason to do it. And in a sense that, you know, Indian science would need to be more than US science. I'm no great Einstein or something that will change the world, but you know, I'm reasonably good. And if I can come back to India, perhaps I can give back a little more. I know it sounds a little, I know I don't like this self-praise kind of the way it is going, but basically that's what I thought, that you know, I will be able to make more of an impact coming back to it. Also personal reasons. I have seen people in the US, and the personal life was very lonely. I'm somebody who would like to go out in the evenings and have, like a true Bengali, have an adda somewhere, etc. Those things, people get lonely in the US. Not everybody, but the standard this thing. You're so dedicated to your work that you don't really have time for it. And soon enough, you grow up and then you have very little time. And I was befriended by some people who are much older than me, who are professors, especially in Cornell, who are of Indian origin. And I could see the life. And ultimately, it didn't look like something. I mean, come on, you have enough food to eat and enough to wear, then really the rest is not about money or anything. But yes, I knew that students, my classmates that I were with whom I competed, not too badly, they will probably end up doing better than me because of the environment that they had. So this was a tough decision. I also, one half of me wanted to compete and see, okay, let's see how good I can be. And this was a tough decision, but I always thought I would come back. I never thought of actually staying back.
All right. So you told us about how and why you choose to go back to India and join TIFR. So can you briefly tell us about your research at TIFR, how it grew and evolved since you joined all the way back in 1998? And what were some of the factors that influenced the trajectory of your research?
Good question. So first, I came back to TIFR because as I was talking about femtosecond lasers, by the time I was coming back, they were buying one. I knew that. And seemed to be the place which is somewhat of had somewhat of an advantage if you're trying to do instrument-heavy research, which is similar. I suspect Somnath's also is similar. And there are not so many options available, so TIFR was one. But when I came back, the other thing that I loved about TIFR is that you decided what you wanted to do, okay? And this is some place where not only you were allowed to do it, you were expected to do it. They didn't tell me, well, most of them, some of them, it's never a black and white story, right? They didn't tell me that you have to keep doing some things and you have to publish tomorrow, etc. Because you start doing some new things, as I soon realized. It takes a long time to start something new in India. Okay, so that's a very sane and sage advice that I would give to anybody, that if you're thinking about doing new stuff, then it takes time to build up. So I wanted to do something that both will have a fundamental intellectual appeal, but will also have some sort of connection to giving back to the society, at some sort of, at least however tenuous, would have that connection. So at that time, it seemed like protein aggregation, which I never had worked on, seemed to be something that I could do and I would like to do, especially because the stuff that I was familiar with, and after all, once you are past the postdoc level, you miss the opportunity that you'd learn something in somebody's lab. All of you know, unless you're doing it with your own hands, it's very difficult to do it. It's okay to read it in papers, something that you have never done, it's very difficult to do. So I knew what I could do. And of course, if you're good, then you can do some things sideways, but not completely different things immediately. And so it was a good match, the protein aggregation problem. It's a good match between what I would really enjoy doing and also something that at that time was sort of beginning to flower. And I thought that the instruments I know how to build can make a difference, that even if you take the rest of the world together, there won't be so much competition. So it's in a way looking for an opportunity where you have some advantages. And seemed like I knew how to build some instruments and would give some advantages. Otherwise, you can also do great research without building any instrument, but you have to be really, really, really creative. So the easy way out is if you can build some new instruments and get some new results, which turned out to be okay. But it was much slower, much, much, much slower initially than I hoped it would be. And since TIFR is, in a sense, small institute, or groups are small, it has always remained slow because always we try to build something slightly new, and it takes time. It takes time, and there are reasons it takes time. You get great students, but then the students haven't, my friends in the US, the Americans grew up when At the age of 16, they were given their dad's old car and said, okay, go fix it and drive it. And my dad always told me that don't touch the radio because it'll go bad and it costs 500 rupees. And so that's the difference, right? So so we do get students who are very good. They have something in here, but they don't have much in here. So that's difficult. It's tough. Things are changing a little bit now, but I won't say it has changed a lot. But yeah, I don't know. I'm sort of meandering a little bit here. So it's Rohit's job to bring me back to the path and let me answer questions that you're really asking. So
yeah. Thanks for sharing your initial journey. So following up Rohit's previous questions, how did you select your research topic initially? Like, is it based on short-term goals, or did you always have a greater, grander vision in mind?
I always want to do, and this is, I would not advise people to do it. I always had the longer term goal. Okay, so the idea was that I will do this, this, and that together. It will gel together into something very substantial. And that is actually not a very great way of going if you don't have infinite number of students and infinite resources in the lab. Because, you know, when you're young, you feel very confident and you say, I'll do that. I know how to do that. Cell culture, yes, I know how to do it. Building a laser, yes, I know how to do that. And, you know, writing a code, yes, I know how to write a code. And we thought that we'll do all of that, and together it will, you know, bring us to the solution of a problem that nobody else believes we could solve. So I would say it was slightly grandiose goals, and we are not 100% successful, but we are reasonably successful. It took a lot longer than I thought. And so the choice of research was, as I said, something that was new that other people were not doing at that time. In fact, for, you know, in 2003, I brought together, I was a very young guy at that time. I brought together lots of physicists, biologists, etc. Not many of them had been working on this. You know, very few of them had been working on the problem, but not many even have thought about it. I really enjoyed that interaction at, you know, making people think about the problem and talking about this. But it was something that was new. It was not something that was, let's say, in vogue. What happens in India, because it's a big country, but it's only the scientists that were really serious scientists are few. So a few guys tend to dominate the themes of research. And if you're coming back from the US, you're not connected to that grapevine. Okay, you don't know that big guy in ISC who does this, or that big guy in you know, ISCS Kolkata or some IIT Kanpur, someplace who is doing that, because you have been away from that, especially if you haven't done a PhD in India. So that was my situation. I didn't know any of these big guys, and you know, being young, you always say, to who the hell cares about those big guys? I know what I want to do. And therefore, my theme was deliberately something that was different from what was in vogue. So that means that you won't immediately connect to a community who you will feed off from. And that's tougher. But I wanted to do that deliberately, and it has worked out a lot.
Yeah. So I understand that your research involves both like developing optical instruments as well as solving complex biological problems. So do both of these aspects always go hand in hand? What do you think?
As I said, I was looking for this opportunity where, you know, I'll tell you how I describe myself. When I meet somebody, I say, look, you know, I'm really a physicist who does some biology, who sits in the chemistry department. So if I meet some chemist, I tell him about some very basic physics that I still remember, not that much I don't remember, and he's impressed. If I meet some biologist, I talk about some chemistry, and if I talk, you know, meet some physicist, I talk about some biology. So I really jack of all trades and master of none, and it's easy to impress others. And but basically, you were asking the question. My answer is that I wanted to wear those two hats together because I thought that's the way that I will make my mark. Okay, and when I was actually running from you know, the cell culture lab to teach quantum mechanics to chemistry students, that there was a dichotomy there that I enjoyed. But it's not, as fancy as it sounds, because anybody who had to pass, as Rohit will know, a comprehensive in physics, know at least some chemistry, some quantum mechanics to teach enough, quantum chemistry to teach chemistry students, quantum mechanics to teach chemistry students. And, I had to do cell culture because I was looking at cells. So it sounds grander, but, I sort of enjoyed this. It just happened to be good in a few of those things. It seemed disparate, but it was not really very difficult.
Dr. Maiti, can you tell us something about the challenges that you had to face in your research career, particularly after you transitioned back to India? And how did you overcome those difficulties?
Yeah, so the first thing that you'd be, suppose you're looking for a job in the US, many of my friends spent time. Wow, that's a beautiful dog. Say hi. Okay, so is that a concept of startup funding? So that most places did not exist. And if it did exist, then it was very small, not something that you could really start a lab with. And that was actually something that was very tough. Okay? TIFR of 2021 is very different from TIFR of 1998 when I joined. And some of us have worked hard so that it became different. So this not having the independence to buy something slightly expensive was really a handicap, because you're supposed to come in and write grants and get some money, etc. But I still chose TIFR. I was lucky that I chose TIFR. There was money in the system, but there was no way that the money was going to come to a young guy like me. It's a reasonably large sum. And there, of course, therefore, the difficulty was that you didn't have really money to start everything in double quick time. Second thing is, again, TIFR was more advanced than most other places, but there's a bit of hierarchy. And that means that, you walked in, but you didn't know exactly where your lab would be. And it sounds shocking, and I'm telling you, because I also wear the hat of being the chair of the department, that is no longer true. But at that time, it took me a couple of years to get my own lab space. I was an experimentalist, okay? So luckily, I had people who would say, okay, tonight I would not be using the laser. And we really, me and my first couple of graduate students, had crazy working hours. Many times it would be 4:30 in the morning that I'd be walking back. It's the night time that I got for doing the experiments. So if you sort of, if you try to really overcome, you can overcome those. Very soon things started falling in place. And now at least the concept of startup funding is there pretty much everywhere that you want to. If you're applying to a place which do not have startup funding, then I would say don't go there. Okay? But the quantum varies. And so therefore, you still have to apply for grants in many places. Luckily, no longer in TIFR, the quantum is actually comparable to many US universities, but most places you'll have to, but they still would give you something to start to state. But that was one big thing. And do talk, and people do understand that you need to have a space as you walk in as a young faculty, and do talk to your department head, suppose you got an offer from somewhere, about those things, and he or she should be open about this. Sometimes it's tough. It remains tough in TIFR till now to be able to give space, but at least there is an understanding. Look, that space is opening up. Take 6 months, and they promise it'll be there. Things like that. So so space and resources are tough. What really saved me were students. I had only 2. But good students. Young, I was only a few years older than them, and they saw me working hard, and they worked hard as I did, and harder, and it was fun. Ultimately, it was fun, and yeah. So initial years can be hard, and you have to be a little careful.
Yeah. So, Professor Maiti, that's good to know your story. So you have discussed the challenges that you faced after joining TIFR. So can you please share with us some of the rewarding experiences that you had during your research career?
Yeah. I'll talk about the initial thing. So this money was a challenge, but then soon enough, we found out that there are international grants available. Wellcome Trust now has, of course, an Indian grant, DBT Wellcome Trust. At those times, it was, you had to compete with 5 other nations. But I got my first big grant where I could buy a femtosecond laser for myself from the Wellcome Trust. And that I remember jumping high. Our last interview, so there are different stages, was in Malaysia. And the moment I heard that, I got the grant in Malaysia, I remember actually jumping. So that's one of the most rewarding things, because you want to be independent. You don't want to be this, taking these 3 hours between 12 a.m. and 3 a.m. For doing the research. You want to be there so that you can run your lab 24 hours. So there are such opportunities available for anybody, and Wellcome Trust is now part of DBT. Of course, there's more on the biology side, but do look out for such grants. There are some other international grants available. Do look out for such grants, and those become very rewarding experience. But the real most rewarding experience is to teach the students. And as all of you will probably do in some time soon, I went into a PhD program abroad. I was an undergraduate in IIT, and I thought, okay, there aren't so great students who do PhD in India. I was wrong. There are very good students who do PhD in India. For some reason or the other, they don't go abroad. One of the big reasons is that at least people who are coming from hinterlands is, their scores in GRE was very poor. It actually has very little correlation with their ability as a student. But anyway, I'm glad that people still are taken on the basis of the GRE scores, because those guys stay back in India. There are other people who have personal things. It was a very rewarding experience working with the students. And then you get to meet some of the guys. Some of the guys were senior to us, maybe 5-10 years, and they see you trying to work hard, trying to do something new. And they're wonderful people everywhere, of course, everywhere, in the US or in India. They'll come down and they'll talk to you. They'll make facilities available. They'll make phone calls so that things become available. Those are initial days. I was in the chemistry department. Actually, I joined a department called chemical physics. Soon it was turned into a chemistry department. But a lady was the chair of the biology department, somebody named Professor Veronica Rodriguez. Unfortunately, she passed away a few years ago. She was, she took me under her arm, saying that, okay, you are trying to do some biological things. Let me see what I can do for you. And she tried to move weights, and so that my life became a little easier. So those are some of the rewarding. You go down, talk to them, and make them excited about your science. It's really, as a young guy, it was nothing more that you could look forward to. That's
All right. All right.
You'll have fun. You'll have a lot of tough moments, but you'll have fun, I guarantee.
Okay. So we have talked about your research. So let us talk a bit about your some of your outreach work. So you have been involved in a lot of it. You have been, as you mentioned before, you have been secretary of IBS, co-founder and president of Fluorescence Society, president of International Society for Optics within Life Sciences. So what was your motivation for your involvement in these activities, and how have these activities helped boost the scientific ecosystem in India?
Okay, see, I told you that this is one of the reasons I came back to India for, how I can give back.
Mm-hmm.
And what I saw in India is that people's ability to build their own instruments was low. And this is something that I knew, because the moment I built a multiphoton microscope, there are people from all over the place saying that, can I use it? And you know how you build a microscope yourself, nobody else can use it. You and your students can use it. Really, literally, nobody else can use it. Same for an FCS spectrometer. But something like a multiphoton microscope, okay, it has an expensive femtosecond laser, but there is no reason why people would not be able to build their own fluorescence correlation spectrometer, which for Atul and Somnath is a stuff that you can look at single molecule spectroscopy. So I was looking for an opportunity to tell people that I'll teach you how to build it, but it doesn't go down so quickly so well, okay? Because people haven't built such a thing. As I said, we don't grow up fixing our dad's old car. And so that confidence doesn't come, though there are people very, very good. So sometime around 2007, 2008, I was in a conference giving a talk, and then there was actually a visionary lady from the government, from the Department of Electronics at that time, a lady named Nilofer Shroff, and she was in the funding agency. She says, well, why don't you hold a workshop and teach people how to build it? Because I keep saying, it's a little bit of bragging, anybody can build it and all that. Of course, you have never seen it built, nobody can build it. I would not be able to build it unless I've seen it. I used to say that. So she caught me there. She said, okay, you said that, I heard you, teach somebody to build it. I thought about it. I said, I'll come back to you. And I then went back to them. They had that point had a reasonable amount of sum. I said, you give me money for one commercial instrument. I'll build 12 instruments with that. And I will give these away to young faculty members who would have to spend 3 weeks with me, no questions asked, morning to evening. Okay. So they funnily enough, is government, but wonderful things happen in the government. They came back with the money. Okay, they came back with the money through the challenge at me. So I had this 3-week workshop, and I said, I will start with this. So I had to design a lot, but there are Indian companies that I could interact with. They will build some of the things. I started with literally screws in these boxes, quarter 20s here, 3 inches there, etc. And these are lenses, etc. This is a box. And I will teach you in 2 days how to make an instrument that beats the specifications of the commercial one. But 19 days after that, you'll have to build it. Every day I'll teach you a part. You have to build it. And every day you have to finish it. I don't care how late it is. The huge, so it was in the papers, and the huge number of applications. I said, if you're successful in beating the specifications of the commercial microscope, you carry it away, carry it home. So 2 remained in my lab because I wanted to, because there'll be fault hunting things. And 10 groups I selected, 10 group carried them home. Okay. Some groups had to work till 2 a.m. and every morning I started at 9 a.m. It was so much fun. And I still remain friends with all those 10. And some of them are more productive in terms of publishing papers with the FCS machine than I am. And, they're guys, because then other people come to them and they said, I can teach you. This is not a big deal. Okay, so there are other people who have learned from them. And this was so satisfying. It took a lot of work. It took 1 year of my life of designing it, making it cheaper, still not letting things go. And I had students who used to do it for designing things, making manuals. So that actually was perhaps one of the most, outside of direct science, scientific results, the most satisfying experience that I have had. Okay, I remember one part didn't come at the right time. I didn't tell anybody. My student was sitting at the customs because the customs work was needed. I said, today is a cricket match day. So we played a cricket match because actually the next component that I had to put in was. But this is the way we started. So I wanted to do one repeat of that workshop. The first, of course, ended with a conference. One repeat because I'll have to check whether the machines are operating well. That one repeat now had the 12th repeat in 2020 December, and the 13th they're talking about now. The COVID is with us, so I don't know how to do it, but we'll probably do it someday. But it has been really wonderful. And yes, I mean, there are other people who are beginning to start doing the same thing. I started, as I said, I missed the grapevine, the scientific grapevine, forget about this technical thing. So we started a club called Biophysics Club, which is Bombay Pune Biophysics Club. We met twice a year till the COVID struck us. Started in 2013 or 12. Okay, and still going on. There's still things. I think you build a community, with the help of others. And, it's a lot of fun. Otherwise, that's the stuff you miss. In the US, somebody tells you, don't go that way. Don't try to put that company's adaptive optics lens or something, because I wasted 6 months on it. You never get to hear that in India. So you waste your 6 months. So you need to build a grapevine to learn from each other. And it's now much better. Again, I'm not probably being very coherent because I'm just having fun talking to you.
No, it was beautiful. Thank you, Dr. Maiti. for sharing your experience of setting up a research program in India, as well as the outreach aspect to it. The challenges that you faced and the rewarding moments you had would have given you a certain unique perspective on the scientific ecosystem in India. In the next section, we would like to know your perspective on more broader themes related to Indian science. So in your opinion, how has the research environment in India evolved since you started your lab at TIFR almost 20 years ago?
It has definitely become better. There is no doubt about it. A lot more people compete very well at the international level. However, we still do a little bit of, I mean, not a little bit, most of our research is willy-nilly defined by the West. So there is this bit of a bandwagon things, which you have to do a little bit of, because otherwise you don't get published, right? So I would say that we are a lot more visible, a lot better, a lot more is expected of a researcher, at least in the bigger institutes of India, than it was maybe 20 years ago, and people are able to compete. But it has gone in some ways, which is, I would say, a little bit of a bandwagon way. I would like to see in the next 20 years, Indian scientists defining, in the Indian context, the scientific question, because there are lots that connect to the society, but the society is very different in India and in the US. The problems there in the US, where you are, there is a problem in the thing, some problem gets defined at once. There are grants and there are people, lots of people working on it. That same problem comes to India. People start working on that problem, but actually it's not really an Indian problem. We need to graduate to that level where we look at the Indian things. Fundamental science is fundamental science. It's going to remain the same everywhere. But beyond that, when you try to justify that, look, this is going to be useful for this and that, and I'm a bit of a culprit in there. I started working Alzheimer's, where Alzheimer's is not a really well-recognized thing in India. It was well-recognized in the US. But I see that time has come for us to define our own problems, look at our environment, look at our health, look at our whatever issues, define good, intellectually stimulating scientific problem. Not just come in with, oh, I put this guy, this bark extract and that thing gets solved. No, I'm not very fond of that kind of research, but actually define intellectually stimulating areas which has a connection to that. Hopefully it will happen in the next 20 years, please.
So that was kind of leading to our next question as well. So you briefly mentioned like what we have to do to better our performance. So some other challenges that we have to overcome. Can you give us some of the other examples of the other challenges that we have to overcome to better our performance as a country?
See, I think Rohit and I had talked about this. It's the university system, okay? I think we have created a few islands where things are done well, reasonably well, at least. And there is a big gap between that and the next level. So in the US, you have the tenure system, and now we have a tenure system also. But initially, you couldn't have a tenure system, because if a guy doesn't get tenure, many of you guys are very, very good where they don't get tenure because of sometimes bad luck, sometimes not suitability, not a good match for that institute. There's no other place that scientists could go to. Okay. So this is because the gap was so big. In the next rung of institutes, you just have to go teach for the rest of his life. That's destroying a bright career. So this has changed to some extent, but not to the extent that we would like, because in most places still you are not selected or not encouraged to do what you should be encouraged to do, which is good teaching and good research. And very soon, as you go to the state universities and all, there are other parameters that come into play for you to get a job and for you to be judged to be successful. And this has to change. And I would say China has put a very good example. Okay, and lots of universities that I traveled to many years ago have changed. Now you'd see that they have become, even I would say places in Singapore. When I first visited maybe 20 odd years ago, I would say that they're not doing so great. There are places in India which are much better. But 20 years later, you look at some of the top institute in US, etc., they're way up there. And this has happened in just 20 years. And this is because performance really mattered. And that, I think, is something that we'll have to look into. We have this little habit of mutual backslapping. Oh, you are doing so wonderfully, and you are doing so wonderfully. Both of us know that we haven't done anything really great. And so that, I think, we need to go forward with. But it's changing. It's changing, I like. But people have more become, to somewhat of my dislike, not having a long goal, but short goal of, when I meet younger faculty or faculty of my age, I like to talk about science, what is exciting them, what is keeping them awake at night. Most of the time, what I get to hear is that, oh, I have made this, I published in JAX or published in this thing. So that becomes an end goal in itself, and that's a bit short-sighted. Because the environment now, the previous didn't expect anything, now they expect, lots of papers. And paper in a good journal means that's a good science. So the young guys are also, system makes you respond in such a way that they're going for maximum number of papers, publications, good publication in a good journal, and that's it. They're very, very good. Lots of people are very, very good. But I'm lucky in a place like TIFR that I can throw something and be considered not absolutely the scum of the earth by doing something which is not very quantitatively very high, but talking about, thinking about science and doing occasionally something that's slightly new, and I'm appreciated. But that's not true throughout the Indian scene. So you'll have this pressure of publishing. It's there everywhere, and you must publish. The other side, you don't publish anything, that's absolutely the worst. But you must publish, but also you have to, together with that, you have to have 1 foot slightly in the sky. 1 foot on the ground, 1 foot.
So, Professor Maiti, thanks for sharing the challenges that has in the Indian ecosystem. However, we also would like to know what are the unique advantages that India has compared to the rest of the world.
What I started with, students. Students, there are plenty, very good students. And in a sense, lots of things are very cheap. You'd be running around for funds just to support a few students in the US. Okay, half the time, most of my friends, almost all of my friends in the US who are in academia now are writing grants. Here also you have to do a little bit of that, but most of the time your students are taken care of. That's coming. So you are responsible as an elder brother that a guy has to get his salary, right? And that in the US is a tough thing. You have to tell the students that I have money for you, not money for you, and all that. Here, you hardly ever have to think about that. Either the national scholarship or your institute will always pay for them. Okay, so that's a big, big, big plus, that you don't have to physically think about how do I pay this person next year. And then you can concentrate more on your science. That's absolutely true. And so that's a big advantage, I would say. The other big advantages are these, there's little things. You do something little good. I was talking about this mutual backslapping. Sometimes it helps, right? Also. So you do something slightly good and people say, wow, we have done such a wonderful thing. It's not so great and you should know where you are, but it occasionally feels good. It boosts your ego a little bit. So, yeah. So those are the advantages, that you can make a mark, you can be appreciated fairly easier than you would be in some other place. But the real advantage is really the students. You can hire them without having to think about the grants, where to do you get the grants, etc. And you can just focus more on your science than many other places.
Okay.
Thank you, Dr. Maiti. So in your opinion, what are the new research fields that India need to focus on in the coming decade?
See, some of them, as I said already, should be something that relates to India's own needs. Some of the own needs are very India-specific, some of them are not. So we do this discussion, of course, frequently amongst our colleagues here in TIFR and try to focus on what are the things that we should, we have to make hiring decisions. Do I hire this guy who's working in this field, or do I hire that guy? And those guys, you guys should also know where we are slightly focusing on. And those are, some of them are the standard stuff. In chemistry, I can talk about environment, health, energy, etc. And we need to focus on those because we have been consumers of those technology and we haven't been able to really be the inventors of those technology very much. And we need to look at that. You need to look at things which we have, hopefully some abilities for. There are lots of people who do optics, and there are routes from that to maybe quantum computing and things like that. So we need to make a good blend of things which would be focused on immediate or intermediate needs of India and things which are of the future, and not lose a toehold on either direction. And we have mostly been driven by what the West defines as good science. And they're good. There's no doubt about that. And some of us must be doing that because the next technology might come from that. But the next technology may also come from something that we focus on in India. Yeah. So I would say the standard stuff, health, energy, environment, etc.
Okay, so Professor Maiti, we are moving towards the end of this interview. And in this section, we wanted to get your perspective and advice on a few key points. So we would like to know, what is your philosophy for mentoring graduate students and postdocs?
Throw them off the deep end. Really. Rohit probably knows a little bit about that. Because I think we spoon feed people who are adults, who should be treated as our colleagues, who should be telling us how to do things right and when we are wrong. But we typically don't do that. We tell them, do this, do that, then you do that, and that's a paper for you. No, I think my philosophy has always been, and not everybody has been successful, but I think more often people have been successful coming into my lab and going off from my lab, because I believe in giving them independence. I believe in not helping them when they're stuck with small things, because I know they will be able to overcome that. But just tell them, you're too good to be stuck here. That works wonders, better than telling them, okay, come here, this you do 1, 2, 1, 2, 3, 4, and get on. So I think giving a lot of independence, giving them the freedom to touch instruments. I'm talking for an experimentalist, make their own mistakes. Give them just a few things which will completely destroy a femtosecond laser. There are not too many things that can destroy femtosecond lasers. So things like that, I'm saying. Other than that, you say just, here are things, guys, you try to play with it and do what you can. And turns out wonderful. It takes a little bit more time, but then they go out confident. That confidence will not come unless they have been able to do that. So that has been my philosophy. Treat them as adults and treat them as equals, and tell them, look, roughly this is what it is. You read up the papers, try to do it. A week later, if you're still stuck, I'll come and have a look and try to tell. Not that I know the answer. And many times I don't. I mean, why do I know? How do I know that? Why is he not getting the sensitivity that he's supposed to get? I know. I have to play with the instrument and try to guess something. And but wonderful. And soon enough, they tell you, in group meetings and all, and basically promote criticism of each other, constructive criticism, and always encourage them to contradict you, because if they believe that they know it, and many times after third year or something, they know sometimes many times better than what you do. And we have this round of, creativity sessions. I have a problem, because some student has a problem, I throw it up and to everybody saying, look, think about it, come back tomorrow. Let's come back to it. Many times somebody who is not working on that field comes back with a good answer. So ultimately, they're as good as you are, for many of them. Just that to get them to believe that they are. They have to believe that.
Okay. So just to follow up on that, so what are one or two key points of advice would you give to Indian grad students and postdocs currently pursuing their research, both in India as well as abroad?
One thing that I will say is that all of us, when you grew up, and probably you guys too, if you are into research, we are only thinking of academic research. India has now some industrial research, but more people should think of that as a career option, not just because it's unsustainable that everybody produces 10 students and there'll be 10 positions for those 10 students. That is obviously unsustainable, but also there is so much good things to do in applied research. And some of my students have become entrepreneurs, and it works wonderfully. Sometimes there's a lot of fun on the other side. And so all of you should think of, when you think of, let's say you're thinking of coming back to India, again, advise you, if you want to stay back, that's a different word. But if you want to come back to India, think of both of these things. Think of possibilities, and you'd be really valued if you can generate technology, and think of entrepreneurship, even within academia. That's an angle that's opening up and being valued a lot. So think about those things.
Dr. Maiti, before we conclude, what advice would you give to a new faculty starting out their research career in India?
Don't go overboard either way. That is, in your research, you choose a problem. Don't choose a problem that you believe will get you a Nature paper, but it will take 5 years. That's stupid. Okay, you think about that, break it up into steps where you would be able to get a result in a year or two. I've seen these things, very bright guys, not really succeeding because they had set their goals in one chunk too high. Set your goals too high, very high, absolutely. But remember, there are steps that you can also get results. That's very important to know. But don't go overboard the other way also. You know that you can do this and make that material, get a paper, make that other material, get a paper. Soon enough, you have 5 papers, but you really don't know what to do beyond that. So I think this, from the day one, strike this balance. Okay. Advice number 2 is reach out. Reach out. You may think that, oh no, in my field there aren't so many people, or the people who are there are not so good, etc. Reach out, you'll see there are people who are good and who would be able to help. And initially, I learned it by mistakes. Initially, I didn't want to go to any of the Indian conferences, because I said, look, I go to the US conference, once a year or something, and most of these research is not of the greatest quality. So that was very stupid of me. And because you make connections, many people are very, very good. And these connections are important. As I said, you miss that grapevine when you come from the US. You've just come from a lab which is probably very good, very well recognized. But that's one area. That lab would not sustain you. It's unfair for you to think of that lab sustaining you for a long time. Keep those connections, but do make new connections. You'll be surprised that if result that got you a let's say PNAS or science paper very easily from the old lab, and where everybody recognizes you and your same result you produce here, same quality result, nobody is going to publish it anywhere, because there is a name recognition that you had. And come to reality that you'll have to, don't say, no, I'm not going to go to that journal for publication. It's important to keep a trail of publications, but it's important not to get stuck there.
Okay,
so it would be easy.
Right. So yeah, so those are like really great words of advice. We'll conclude the interview now. So on behalf of Sci-ROI, I'd like to thank you very much for taking time out to share your experiences with us. And we are sure our members have learned a lot from this discussion with you. So thank you so much.
Thank you for having me. It was wonderful chatting with you, young guys. Hopefully, we'll see some of you sometime soon in the Indian academia.